I'm Mr. B, and today we're dealing with sequences. Sequences, fancy word, dealing with patterns. Here I have my pattern here. I first have to decide if it's an arithmetic or a geometric pattern. Arithmetic means adding or subtracting. 5 to 8, 8 to 11, 11 to 14, 14 to 17. What am I changing by? I'm changing by plus 3, plus 3, plus 3. That's my pattern. And since I'm adding, that means it's an arithmetic pattern. Cool. Once I know it's an arithmetic pattern, I can then create a formula that describes it. Seems kind of crazy, it's really not. Here's how the formula works. It's going to be a to the n, which is any term that I want, is equal to a1. That's my first term. What's the first term here? 5. Plus, what's the common difference? Common difference is a fancy word for what is the pattern. What did we say was going on here? We're adding 3. Cool. And then it always is n minus 1 at the end. And that's how I describe this pattern in a mathematical formula. A1 is my first term, D, my common difference, or my pattern. And you might be saying, what's the point of this silly formula? Why are we complicating patterns? The benefit of this formula is now they can ask me, what is the 51st term in this pattern? If they ask me, what is the 51st term, I can then take this n, which stands for number in the pattern. N is any number in the pattern, and I can plug in 51 there. And if I plug in 51 there, it becomes 51 minus 1, which is 50. 3 times 50 is 150. 150 plus 5. 155 is my 51st term. That's the benefit. If I want the 81st term, plug in 81 into the end. If I want the 87th term, plug in 87 into the end. Cool. Let's do another one. I'm going to keep my formulas up here though. What if I had 10, 4, negative 2, negative 8, negative 14, and so on. First, I have to think, what type of pattern is this? And I see I went from 10 to 4, I went down 6. 4 to negative 2, that's down 6 again. Negative 2 to negative 8, that's down 6 again. So my pattern is down 6 or negative 6, and that's adding or subtracting. It's subtracting, so it's an arithmetic sequence. So I write my formula, a(n) equals, my first term is 10, plus my pattern, or my common difference. We said the pattern was minus 6, so I put a minus 6. And then it's always n minus 1. And the n minus 1 is there if I want to plug in any number I want to find. I can plug in 51 there, and it'll tell me the 51st term. And I can plug in 201, and it'll tell me the 201st term. But this is the pattern for that. Cool. Let's try again. Let's try 4, 12, 36, 108. Dot, dot, dot. Okay. I'm now going to figure out what is the pattern here. This was plus 8, right? 4 to 12 is plus 8. But 12 plus 8 is not 36. So I see I'm not adding something here. I'm going to say that again. I do. 4 plus 8 is 12, but 12 plus 8 won't work. So it must not be adding. Instead, it must be multiplying. 4 times what is 12? Times 3. 12 times 3, 36. Okay, cool. So my pattern is multiplying by 3. Since it's a multiplying pattern, it must be geometric. The geometric pattern, or the geometric formula, is very similar. It's a(n), which is any term that I want, is equal to my first term, which is 4, times my common ratio. Similar to common difference, common ratio is just a pattern. But if I use the word common ratio, I know it's geometric. If I use the word common difference, I know it's arithmetic. My ratio is what I'm multiplying by as my pattern, which is -3. Sorry, not -3, just 3. I'm going crazy. Because I'm multiplying by 3. Now, the only other main difference between arithmetic and geometric is in arithmetic, the n-1 is here, next to it. In this one, it's up here in the exponent. But it's the same exact thing. Now that I have the formula, I can find the 5th term or the 51st term in my sequence. If I wanted to find the 5th term, I would just plug in 5 here into the n. And what is 5 minus 1? That's 4. And now I gotta do 3 to the 4th, which is not 12. It's 3 times 3 times 3 times 3, which becomes 81. And it's 81 times 4, which is 324. And that's my 5th term. And that's the benefit of the formula, is I can plug in any number I want. Well, lastly, the only way this gets a tiny bit more complicated is with this. What if I had this pattern? Okay, so I looked at what happened. I went down 150. Okay, maybe it's minus 150. But what is 150 minus 150? Is it 75? No. So it changed. It's not changing by the same amount. Therefore, it's not arithmetic. I'm not subtracting the same thing. I must be dividing or multiplying by something. I went from 300 to 150, 150 to 75. What am I doing? I am dividing by 2. If you don't see that, you can just do, hold on, let me get to that 1 second. I'm dividing by 2. I'll explain if you don't see that in a second, but I'm dividing by 2. That's my pattern. The problem is my formula doesn't let me do division, it's multiplying. So I have to find some way to say dividing by 2 in a multiplicative way. But remember from fractions, we remember that keep, change, flip rule that we're supposed to do with fractions, that we can also do with regular numbers, because fractions are just numbers. Dividing by 2, keep, change, flip, is the exact same as multiplying by a half. If I flip it, and that's the exact same thing as multiplying. Dividing by 5 is the same thing as multiplying by 1/5. Dividing by 4 is the same thing as multiplying by 1/4. So if I know that, I can write my formula as a to the n is my first term, and then I'm multiplying by 1/2. And since it's geometric, it's n minus 1. If by chance you can't see it's dividing by 2, or the pattern's more difficult, you can take your calculator and you divide the second term by the first. 150 divided by 300. If you were to simplify that, you would get 1/2. Then you could test it by doing 75 divided by the number in front. 75 divided by 150, that's also a half. If you do the math to simplify it. And that's where 1/2 goes. Your calculator can just tell you that right away. This is sequences as simple as I can make it, I think. I hope that makes sense.